Hey guys, and welcome to part 3 of section 5.6 video notes. Now we're going to get into the chain rule for FTC part 2. So if f is continuous on the closed interval, and we have a function g of x defined to be the integral to some function of x, then it is continuous on that closed interval, and the derivative is f of u of x times the derivative of the function on top. So let's do a quick demonstration so you can see how this works. So let's define g of x to be the antiderivative from 1 to sine x of, let's say, t dt. So if I were to take the antiderivative of t, that is t squared over 2, and that's going to be evaluated from 1 until sine x. So now that makes g of x sine squared x over 2 minus 1/2. So now I need to take the derivative to see what I have. So we have g prime of x now, taking the derivative of here. Now this 1/2 I'll pull out in front. The derivative of sine squared first, I'll do power rule times 2 sine x, and then the derivative of sine x is cosine x, and the derivative of negative 1/2 is 0. So g prime of x is sine x times cosine x. But if you notice, that's the same as plugging in sine x for our function of t and then multiplying by its derivative. So we can go straight into this rule as long as we know we're using FTC part 2. So here in part 1, we have a problem that's beautifully set up. In order to apply FTC part 2, we're going from a constant to some function of x, and we're trying to find the derivative. So by FTC number 2, that's going to become 1 over x squared, right? I just take the x squared and plug it in for my variable, multiplied by the derivative of x squared, which is 2x. So my final answer is 2 over x. So you could take the antiderivative and plug it back in, but FTC number 2 shows us that we will just plug back in our function on top and multiply by its derivative.